webinar, and my name is Ruchika. I have conducted various training sessions in big data for US training companies. I'm a CERN certified Java developer as well, and I have more than 6 years of experience in IT and as a trainer in Java and big data technologies. And I am also facilitator and trainer with 4 years experience in designing the programs for big data content development and online training in Java and big data. And I have also developed 3 courses of big data that are published in Udemy now, and they have more than 7,000 students enrolled, and they are across 100 countries. So that is one of the achievements. And now the course outline, what we are going to discuss about is in the whole course curriculum, we have the introduction to big data and Hadoop. We have HDFS, MapReduce, Quick, Hive, X-Base, Uzi, Scoop, Flume. So these are some of the course Hadoop ecosystem, the components which we are going to discuss in this course. So before that, I would like to know about you people. Can you please, in the chat box, can you drop what is about yourself, means what is the technology you are working with? I would like to know about that. So are you people who know Java and Unix or SQL? Do you have the basic knowledge of Java, Unix, and SQL? So please just can you bring in the chat box about yourself? A bit I would like to know before starting for the course. Okay, yeah, Java knowledge is not required in depth. It's just the basic Java knowledge is a little bit required, and Unix and SQL knowledge. Okay, yeah, a few people are sharing their experience. Yeah, seems little bit knowledge of Java is there with people, and SQL also. Yeah, SQL also will require basic knowledge, not in depth right now. Okay, you're already working on, some people are already working on SQL, Python, and Tableau. Okay, so seems like most of the people, some have knowledge of some or the other programming language at least. So that will make it easier for them to follow our course. That's great from you people. Okay, so these are some of the topics that we'll be discussing. So people who are working in SQL can move to Hive, which is the components that deals with the Hive queries that are quite similar to SQL. So for making a transition from your career to big data, main tool you'll require is like learning in depth about Hive. Okay, that is one of the components that will require for sure. And for the analysis, especially this Pig and Hive, both are used for the data analysis. So before starting any course, like I know most of you must be familiar with what is big data, but might be possible that some are fresher to this new technology, they don't know what it is. So quickly we'll go through what is big data and how big data came into picture. So how this big data came into picture is like earlier what type of phone we were using, we were just only doing calls and some of the text messages. And you can see the difference with the coming of the smartphones, the different apps you're using for music, sports, games, social media, chatting, and so many applications you are using that is generating huge amount of data, right? So that is how big data came into picture, where you people and so many companies, everybody is now generating that huge amount of data. So actually what is big data? So big data is like, if I give you example of any, you're visiting some, you're going to some shop and you're buying supermarket, and supposing you're buying a toothpaste, okay, you buy a toothpaste and after this is there is a pattern, like after every 3 months you buy a toothpaste. Okay, so the specific Pepsodent, supposing you every time you are buying the same toothpaste and every 3 months you're buying. So what the company will do is that they will find out this pattern. Okay, if this person is particularly using this product buying this product every 3 months, and the same product he or she is buying, they'll get that patterns out of that the data. Means they will find out your pattern of buying the products, and they will supposing they will give you some discount on that product, that will actually motivate you to buy that product from their shop only, their supermarket only. So what is this big data? It's like extremely large set of data that is analyzed to reveal some patterns or trends. So you have these, this is where this data is now very important for companies to get the patterns and the trends in your marketing, your shopping, and especially what is related to human behavior. And finally it predicts something useful. Okay, this is the pattern they are following every month, and they can do some give you some discounts on that. So the data is growing, and the result is this huge amount of data. So this range from terabytes to yottabytes is actually considered big data. So now Facebook and all these sites are actually generating huge amount of data, and Facebook alone is generating in petabytes, 300 petabytes of data, more than that. So this hierarchy shows that how the data is growing, and this range you can consider it to be falling in the range of the big data. So how this data is growing, that you see that you are using so many social media sites like Twitter, Facebook, you are every time you're sending 325,000 tweets, or means this data is just growing. You're uploading photos on Facebook, you're uploading videos on YouTube. So it's estimated that approximately by 2020 this data is going to be growing around 40 zettabytes of data. So you can imagine how much data it's going to be generated, and this massive amount of data is what generating is called big data. So data is the new oil, and we need to find it, extract it, refine it, distribute it, and monetize it. So that is very important. So big data is an asset, and data is the currency. So that is very important to leverage the use this data to analyze something useful, and also the most important part is monetize it. So earlier the companies were really throwing away the data, but now it's not possible because there is so much competition in the market. When the data is growing, you cannot just throw away that important data. You need to analyze it and improve your market presence. So is this data, big data, really valuable? Yes, this is really valuable because you see Amazon site, you must have seen when you do an Amazon search, you're supposing searching for a gaming mouse. It gives you personalized experience based on your search you have made on Amazon site. So you will get some recommendations. Recommendations are everywhere. You see Netflix recommending about the movies, and Amazon it's recommending about the products, books, anything. So you get the recommendations. So how is Amazon throwing out those recommendations? That is all because the data it's having from the searches of so many people, so many customers. It's leveraging that data and analyzing it, and on basis of that, it's showcasing the recommendations to you. So this big data is really valuable. You know, it makes customers happy because they have the personalized experience. They have their own recommendations. There is one more example, like this Google revamped is using play music. There is optional recommendation based on your locality. So supposing you are walking into gym, it will recommend you some workout music. Okay, and if there is a, if there is sunset, some sunset soundtrack will appear. So all these recommendation of music, Google has come up with this play music. Then one more example I give you is the location-based ads. So mobiles are ubiquitous; they're everywhere. Supposing I take example of Big Bazaar. Now you are just moving around Big Bazaar and you have been a regular customer. Now they come to know, okay, that you are near Big Bazaar. Let me send them some discount, and they will be surely tempted to visit the center and get the products. So for that, Big Bazaar has collected huge amount of data, right? It has to collect using GPS. It needs to know your geolocation. It needs to collect that location of the mobile users. It should know your profile and preference, your surfing habits, and they also need to know your recent purchases. Supposing you have been purchasing toothpaste always from there, so they'll give you a discount, saying there is a discount on the toothpaste you buy. So Big Bazaar has to keep actually a lot of amount of data, so that it can give some real-time based location ads using GPS. So this huge amount of data, it needs to keep it, just cannot throw it away. And this is the data they are leveraging and giving benefits to their customers. So that makes them really stand out in the market. And so now you can understand how important these days this has become. This is not just an example of Big Bazaar. This is actually with every company. Now, every company has to deal with this huge amount of data. That's why you can see there is a lot of growth in the market. There is a lot of job opportunities in the market related to this field, because now each and every company has to be to stand in the market. They have to just leverage the benefits of the big data and analyze that huge amount of data to be there in the market. Another example is like Make My Trip and all these Yatra.com. They're also leveraging the benefit of big data. Means based on the search, supposing you're searching some hotels, and then the result will be based on what other customers chose on that particular search. So that amount of data it's saving, and its result will be that customers don't have to go through a huge list. So that really makes customers happy. Instead of searching for huge amount of data on the site about the hotels, it can just go and just make a search, and this makes it the customers really happy. So giving them a personalized experience. So all the industries, almost all industries are using big data, and they're transforming their business models and improving performance in these areas, like in retail, manufacturing, in energy, financial services, advertising, and public relations, government. So all these sectors all are using big data. So you can understand how much there is the huge demand in the market for this technology. So big data is a misnomer. It's not just about volume. It's much more. So we just talked about, okay, this is huge amount of data. Big data is huge amount of data, but it's not just volume. It's about few more things. So this is the 3 V's of big data. We'll be talking about the velocity, volume, and variety. So volume, we just talked about that we're going to generate huge amount of data, 44 zettabytes of data by this end of 2020. And variety, by variety means we have different forms of data. We have data in the form of tweets. We have data in the form of videos, Facebooks, sensor data. All this data means now the data is not only structured. Earlier we were dealing with only structured type of data. Now because companies have their log files, web logs, then they have they have social medias where they want to collect the data from. Tweets, Facebook, people are following them on Facebook, Twitter. So all that type of data now they want to collect and analyze it for their better growth in the businesses. So that is one of the challenges that with big data it's coming. It's not about only the volume. So variety, there's a lot of different forms of data that we have to deal with now. So how to deal with that different forms of data? That is one of the challenges. Another challenge is the velocity. I'll give you one example. While you are surfing on Amazon and searching for some product, like you are searching for some gaming mouse, at that very moment, you get a mail, okay, there is a discount on this gaming mouse. So how did they catch that? Actually, they are analyzing the data in that streaming data in real time. They're analyzing the data while it's coming into the system. While the data is coming into the system, they are just analyzing it. So this is analyzing of streaming data. So that velocity, so we have to deal with the velocity, because if you give the discount, if you send the mail of discount the other day, by the time that customer must have bought from some other place. So you have to be very quick in analyzing the data, streaming data. In real time you have to do the analysis and give the results. So that huge velocity is also, the data is coming with huge velocity into the system that you have to analyze and give the results. So these are the three V's. We discussed the volume, variety, and velocity. That are the challenges we are facing when we are having the big data. So volumes of data can be from sensors, personal health trackers, social media that are human generated. Then the organizations are also actually generating huge amount of data in the form of credit card information, medical records. So big data is now these days used in finding out about the diseases, and all that data is analyzed on the experience of the patients, and that is giving help to other patients. Velocity is the rate at which data is coming into the system and the rate at which it needs to be analyzed. So speed of processing should be faster than new arrival of data. So that is what we have to deal with, the huge velocity of data. So variety we just discussed, structured can be your relational database, your Excel sheets, like these files, they are structured data, but the data which do not have some defined pattern like the tweets, Facebook, YouTube, images, or these mails, they do not have a defined structure, the combination of different types, like the weblogs, they do not have any defined structure, so they are the unstructured formats that we have to deal with. So what is the solution to this problem of this volume, velocity, variety? What is the solution? The solution is the distributed system. So okay, we don't have a drawing tool in this. Okay, no problem. Okay, so the idea is, now supposing you have a high-end machine and you have here 100 terabytes of hard disk. Okay, 100 terabytes of hard disk you are having. So you want to, now you can store up to 100 terabytes of information here, but what will happen now when your data starts increasing? Now supposing your data is now 200 terabytes. So you want to store 200 terabytes. So what you will do is you will increase the capacity of this machine, make it to 200 terabytes. Now more data, then there is some, you can increase the capacity, but there is some limit. Up to what limit you will increase your capacity? This will become quite complex, and it will also become costly. So this will actually make it costly, as expensive, as well as it will make it complex. So the idea is, if one person cannot do one task, so let's divide the task among more people. So 2 people also cannot do the same task. Let's divide the task among 3 people. Okay. So this is what is the concept about. So this is the concept of distributed computing. So this approach, in which now instead of increasing the capacity of the single machine, what we are going to do is we are going to have some cheap commodity hardwares. They won't be the high-end machines, and we will be distributing the task. Now instead of adding 100 terabytes to this, we will be having one more machine for 100 terabytes. Okay, so this is the distributed framework. So this is good. This approach is good, that we are now distributing the task. Why to do it for a single machine, making it complex? Let's divide the task. If more is needed, let's add more machines. Okay, that is how we are scaling up. But it seems good, but there is one more problem. So this is like a team, but it doesn't have a captain. So how the team will look without a captain? So you need to have a framework which will handle all them together. Supposing there is a failure of this machine, so how others will know about it? Okay, how are each of them going to communicate with each other? Okay, so what how to have a captain over this team? Okay, Or if there is a hard disk crash, there is failure, who will take care of the failure? Who will take care of the coordination among these nodes? So the solution to this problem is Hadoop. Okay. So Hadoop is the solution to this problem in distributed system, where in this distributed approach you need, so Hadoop takes care of this coordination. If one node fails, what to do, all these things are taken care of by the framework called Hadoop. So you need to have this some particular framework which will take care of this network communication and the failures, all these things. So what is a cluster? This is a cluster of supposing 4 nodes, and these are called nodes, and the collection of these nodes is called a cluster. Okay. Hadoop is a framework that is working on this, taking care of this cluster. And in a cluster, these machines, this will now won't be costly because they are not high-end machines, they are the cheap commodity hardware. Just a moment. So the solution to the problem is the distributed system, and problems that are faced by a distributed system are like high chances of system failure, there will be high programming complexity as well. So the solution is, yes, there is any solution, that is the Hadoop. So Hadoop is a framework and it allows for distributed processing of large data sets that will be across clusters of commodity computers using simple programming models. So just now I discussed that it is a framework that will allow you for distributed processing where you're using large data sets and across the cluster of different nodes that will be the cheap commodity hardwares. So the key characteristics are that it is scalable, reliable. So you can just now scale this architecture. You can scale out. You can add any number of machines you want. It is reliable because you can just means you can store. It stores multiple copies. So in case of hardware failure, we'll see that later on that how does it take care of reliability, flexibility, and obviously it's economical because ordinary computers, the cheap commodity hardware, they can be used for data processing. So now you have the understanding of what is distributed system and what is Hadoop. Any questions till now? If you have any questions, you can just ping in the chat box. I will be answering it while I'm taking this session. So this is the Hadoop ecosystem, the Hadoop stack. What we'll be dealing with is these components. So one by one, I'll just give you the overview of what these components are. So core Hadoop consists of two main things, that is the storage and the processing. The storage part is the HDFS and the processing part is the MapReduce. So HDFS is now because you are dealing with distributed systems, so your file system will also be distributed. That's why the name is distributed file system, and that is related to Hadoop. So that's why it's Hadoop distributed file system. So Hadoop distributed file system, the whole architecture, everything, one by one we'll be discussing all these components. So basically now, instead of storing file on one system, we are dividing the file into blocks and storing into storing that those blocks onto multiple nodes. Okay, so that is the idea of distributed file system. And processing part. Now core Hadoop consists of storage. Now you have stored the data. Obviously now you want to process it, analyze it. The storing part is taken care, like the challenge of storing huge amount of data is taken care by the HDFS. Now you can store your data across nodes easily using this type of file system. Now coming on to MapReduce, it's also one of the core component of Hadoop, and that is used for processing part. So MapReduce component also will be discussed in detail. What is MapReduce and how it's dealing with the processing of data in HDFS. So MapReduce will just, the data that is stored on different nodes, it will run those MapReduce jobs on them and then process that data. Doing any processing like counting number of words or finding the maximum temperature for say example. So because the data is huge, it's just distributed among nodes, and it will be analyzed using MapReduce, processed using MapReduce. That is the MapReduce engine that is working to process the data. Then you can see on the left side there are two components, that are scoop and flume. So now you want to ingest the data into this. Supposing now you have data in your relational databases, okay? Now you want to get that data into Hadoop world. Because you want to analyze that huge amount of data, you have to get that data into Hadoop world. Means you have to store the data into HDFS. So for getting that data, you need some tool, and that is scoop. And flume is also, so first thing what you do when you start any project is the data ingestion part. So data ingestion means getting the data into Hadoop world. So how will you get the data? You'll use scoop. Scoop is for basically getting the structured data, that is the relational databases, data from relational databases to the HDFS. Okay. Then flume is generally used for the real-time data, like the web logs or the tweets that are getting generated in real time. So those type of data that are generated in real time, that flume is the tool that is used to get the data into HDFS. So there are a lot many tools that were added after this core Hadoop was there, because these components actually help in getting the data, some will help in processing. So core Hadoop but consists of these two things. Other tools got added according to the requirement of the people. They started adding new components. Then you can see Pig and Hive, they are on top of MapReduce. So Pig is Pig and Hive both are used for data analysis. Like Pig is a scripting language. It offers a scripting language called Pig Latin, and whatever the scripts you write that are getting converted, that get converted into MapReduce jobs. So Pig was developed by Yahoo and Hive was developed by Facebook, and later this they became open source project under Apache. So Hive is also Hive is a tool that is greatly used by data analysts to analyze the data. So these two components means analysis can be done through MapReduce, but these two components got added because these people in Yahoo and Facebook, they were finding it MapReduce very complex. So they added components which were suitable for their company, and later on they made it open source for other people as well. So Hive uses a SQL-like language called HiveQL, which makes it very easy to analyze the data. Mahout machine learning we won't be discussing because this is now obsolete, because after the coming of the Spark, now Spark machine libraries are much faster. So in market nobody nowadays is using Mahout for machine learning. Then Oozie is a workflow engine. Now supposing you have many things like Pig, Hive, you want to have your job you want to run for Pig and Hive you want to run together. So you can define a workflow using Oozie. Then you have a HBase. HBase is a NoSQL type of database. Okay, so we know SQL databases, but there is a concept in big data world that is called NoSQL database. So it's not just SQL, but it's more than SQL. So we were dealing with row-oriented format data stores, but this HBase is a columnar data store. So this HBase is also in the one of the components in Hadoop, and it's working on top of HDFS. So it's a database. So these components one by one we'll be discussing in each class, like what is HDFS, MapReduce, their architecture, hands-on. We'll also be doing hands-on on these topics. Then one more thing left is the zookeeper. So zookeeper, now you see there are so many animals in this picture. So we need a zookeeper to actually take care of these animals. And I mean, zookeeper is a coordination system in Hadoop that is used for the coordination purpose of all these components. So we will be dealing with one of the distributions, that is the cloud era. So cloud era, I just want to walk through that cloud era. So you need to install this. For working on these components, actually you need to okay. So you need to install Cloudera, that is Cloudera Quick Start VM. We'll provide you the procedure how to download and install that. You have to go to Cloudera site and you can download this Cloudera Quick Start VM. And for this, you need Oracle VirtualBox. So Oracle VirtualBox, after you download install, then you can add this Quick Start VM in the VirtualBox. After you are ready, you can see this screen of Cloudera. Here, this is a virtual machine, so it has, it's like a machine, different operating system. Here you can access these commands using the command line tool you are provided. Then you have this browser also. Okay, so you have this browser. So just quick overview, like on this command, if you want to see the files present here, so you'll use this ls command and you can see the list of files present there in your local file system. Now if you want to access your HDFS, use command Hadoop FSLS. So this is quite similar to the Unix command. That's why I was asking that if you have a little bit knowledge of Unix, it's good. So if you know the how to list the files, then for listing the files in HDFS, you need to just say Hadoop FSLS. So this command will show you the list of files that is present in HDFS. Okay. Then we have this web browser. Here web browser, if you go to view, you'll need to log in. So login and password, here I've already logged in password. So when you go to this browser from here, it will open this web browser. Here you need to log in with Cloudera. Okay. You'll get a prompt to log in, write the login and password. So there you have to provide Cloudera. After that, you will be taken over to this web browser. Here, I would like to show you Hue. So Hue is Hadoop user experience. In this, all the components like first you can see here. Here you can see we have the query. Just a moment. I'm hearing some noise. Is it anybody on? Hmm. And Supriya, can you mute yourself? I'm not able to mute. Okay, thanks, Supriya. I was getting some background noise there. So this is a quick walkthrough. I'm going to browser. So here you'll see there is a query editor, Hive, Impala, Pig. The components we'll discussing, you'll get everything here. You can run your Hive. Any questions? Okay. So this is hide. Here, supposing you want to write some query and run it, it's very easy to do that. It's similar to SQL. Okay. So this simple queries, you get the tables here. By default, it uses a default database. Then you have other components as well. Means it's quite easy through Hue browser. All the things which you can do through the command line prompt, you can also use web browser, the Hue Hadoop user experience to do that. So here you can write the pig Latin statements and run those scripts. So yeah, you create scripts in pig. Then this is Uzi we were talking about. So uh, we'll be talking about Uzi in detail. I just want to show where it lies here in this. So here you can see you can create a workflow here. Okay, all this is quite easy with this component. Then important thing is this file browser. Here you can see your files in HDFS directly here. So it's very easy. Like we listed out the files Hadoop FSLS using the command. Here by default the directory for HDFS is /user cloudera. So here you can see all these things, listings of files and directories we have. So we can perform lot of things here. We can perform actions like we can rename, move, copy. We can change the permissions, the read, write, and execute permissions of the user group and others. If you know Unix, you know what is this permission all about. Okay, so you can do a lot of things here. You can upload the file from here. Then you can create a new file or a directory, and then finally you can move it to trash also. This is very easy, simple to use from here, but there are commands. So HDFS file system you can access either through these command line prompt or here. Okay. Any questions till now? So anybody has already installed this Cloudera? Like some people, they do try to so anybody has installed or you all need to install it? Okay, you need to install. Aditya has already installed. Yeah, most of the people must have already installed. Okay, let me share the just. Aditya is asking, as Java developer, how can I transit to big data domain? So it's like there, if you see the requirements, you'll see that they require Java knowledge beforehand. So Java developers have a bigger edge for as a big data developer, they can move to. So always they'll be asking good number of experience in Java, then they'll be asking to switch to big data. So internally in your company as well, I think so you'll be preferred if you have good Java knowledge, you can easily transit to big data domain. Other advantages that you will be after this big data course, obviously now the market is moving to Scala and Spark. So you definitely need to go to that course as well, Scala and Spark. So Scala is very much similar, means if you have good Java knowledge, then moving to Scala is also very easy. So having knowledge of Java is really important in this. And SQL, PL SQL, I just told you, like in this Hive is one of the components you need to switch to. So your company will require you to have SQL knowledge to work in Hive. And then after now the market is moving to Spark. So the Spark SQL integrates with Hive. So after that, when they'll start working on Spark SQL, again there is one library component in Spark, that is Spark SQL. So that is also you will be working on those components, Hive and Spark SQL in your company, if you are already working in SQL and PL SQL.
Yeah, hi. Sorry to interrupt you guys. Rita, I'll just like to elaborate on Aditya's question. Okay. So, since Aditya, you have worked in Java, okay. So, talking about Hadoop and ecosystem, so there are three prospects of it. Okay, we have admin, we have developer, and we have analyst. Okay, so if you segregate this into three different part as a job profile, then Java and knowledge of Java and any programming language, hands-on programming language will fall into a developer category. Okay, if you have a good skill sets in like querying language like SQL, R, Python, okay, then you are most probably like falling in the category of a analyst. Okay, so there we don't have to write MapReduce code using Java, but we use SQL and other query language to pull the data. Okay, like SQL, like Ruchita what said, SparkQL and all. Okay, and I have also seen some guys who have experience in Unix and some scripting languages, if I'm not wrong. Okay, yeah, C, Unix, Linux scripting experience. Okay, like Satyasi. So for her, like for him, the most appropriate for his skill sets, the admin kind of thing in Hadoop. So like what on a nutshell, what I like to tell is like whatever programming language or experience you have, definitely you can convert that into a Hadoop and big data ecosystem. Yeah, thanks. Rishida, you can continue.
Thanks, Ajit, for adding all these things. Okay, Aditya has one more question. So Spark will take over Hadoop. I was reading articles, companies are now not using MapReduce. Yeah, that is true. So in this course also, like normally now the training companies or anybody, they are not focusing much on the MapReduce Java programming. But still it's not that companies who are already using MapReduce. See, MapReduce is working on the batch processing, while the Spark is working on real-time processing. So there can be different use cases, like where you want just batch processing and you don't want real-time processing. So in that case, you won't be using Spark, right? So it's not that Spark is taking over MapReduce because it's faster. And MapReduce, it's basically more suitable for both. It's used for both the things, batch processing as well as real time. Because it's of its speed, it's faster. People are moving to Spark. That is true. But in very few cases where the use case is still that we require batch processing. In that case, we will be still using MapReduce.
Yeah, great. And to add to Ruchika's point, okay, on Aditya's question on Spark and taking over Hadoop and MapReduce, yeah, that is happening currently if you see the current industry scenario. But again, the things which are there, you cannot replace it completely. A very good example of that will be a mainframe. Okay, in-house mainframe systems that is being used by major companies. Okay, that is outdated and everyone knows that. Okay, that is been overtaken by cloud, the data centers and all. But still you will find many companies have opportunities and work in mainframe, irrespective of the latest technology. So it all depends on the requirement and the company, how much he or they are trying to invest on that particular technology. Because using Spark, is not a very easy deal because it needs a very good infrastructure. Okay, infrastructure as in like from end to end infrastructure. Okay, but MapReduce can work in a like a very less cost effective way. So again, it's a company call, and I can assure you nothing will replace anything. Like MapReduce will not be completely replaced. You will be finding MapReduce tasks happening sometime everywhere. So Ruchika, like the installation of Cloudera. So like, are we good to are they good to install themselves? Because what I find is like we'll just share a document with them. I have a document, okay. So they can just go through it, and it's an easy process. You first need to download VM, okay, Oracle VM, okay. Then you,
Sharing, please
yeah,
open the
that will be covered actually. That will
document.
be covered as a part of this course, okay.
Yeah, so step one, you download the virtual box. Okay, after you download the virtual box, you'll get some link then. Okay, once this finishes, Oracle virtual box, then you need to install Cloudera in Oracle virtual box. Okay. This is the virtual box manager window. Here from the file, you will just, okay, from Cloudera website, you'll go to Quick Start VM. You should have minimum 8 GB RAM in your system. Then you need to extract files from this. Just add this in the virtual box. It will be shown here. Like this it will come. Then just you need to double click and start it. This is what I showed you. So this is very important to install. So your first task should be that you should quickly download this
Ruchika,
because we'll
they
be
are
doing
not able
hold
to.
and on.
Sorry, Ruchika, they are not able to view your screen. I don't know. Like, can you please share your screen once again?
So I have shared.
Okay.
Mm,
Guys, are you able to see the screen now? No. Okay.
what is the issue I have shared?
Oh, wait. Ruchika, I have made you a presenter now. Can you please share it again once again?
Yeah, we can see your screen.
Guys, just refresh it because I can see some ping. Some guys are pinging that they are able to see the screen. Just refresh it once. It is fine from her end. Okay. Great. So just a note of confirmation. If you can see the screen, just press yes.
Can you see my screen?
Yeah, yeah. Some guys now.
Now fine?
Yeah,
Okay, so
Satyasi,
you need to download the
Satyapati.
virtual box or you can download this. Then after download, you need to install Cloudera in Oracle virtual box. So here, as I know this document, we'll install Cloudera in Oracle virtual box and just add it the virtual box. Just run it, you don't have to do. So it get back to you with the solution. Any other questions? I have to leave. Aditya saying I have to leave. You will get the document by mail.
Like those computers who don't have 8 GB RAM, any other software options for that.
For that, you can access some online cluster. Okay. So online people are giving a cluster for free, some are giving paid. So those labs online you can take. You have to buy them. Some are giving free
Okay.
trial for 1 month. That will share later on.
Okay, it would be good if you have some link, this kind of link you can share. It will be good for us. Thank you.
Okay, I'll share. We'll share on mail. Because RAM is this for Cloudera, you need more RAM. Otherwise, your machine will be slow. And there are a lot many vendors out in the market who are taking this. So we just share the real-time clusters. Okay? There you have to pay for the fix. One is the CloudX Labs. CloudX Labs. Online practice platforms. What type of online practice platforms do you use? See, Cloudera we are working, so we are on single node, right? Our machine is just a single node. So if you what do you mean by real-time cluster will be like you will be having many multiple nodes there. See here, if you go and see here in Hadoop, we have the data nodes, the nodes which we have. Next class I'll tell you what is name node, data node and the HDFS architecture. So next topic we are going to cover is the HDFS and MapReduce. Okay. So here you can see live node, dead node. So we have only one node out here, but in real-time cluster you'll be having multiple nodes, right? So here all the information about the nodes is kept. Any other question? How about NoSQL with big data in future? Should I need to practice NoSQL? Yeah, NoSQL is actually a lot in the market. NoSQL databases, there are a lot many used in different scenarios. So one of the database we'll be discussing will be Edge based. Other is like Cassandra. Many people are working on Cassandra. That is also one of the type of NoSQL databases. So good knowledge of NoSQL database is important, but NoSQL databases are many. It's not just one. Okay, but if you know what is NoSQL database, how they work, that is fine. But in market, there are lot many NoSQL databases are used that are quite different from each other. They are not like SQL. Like if you learn MySQL, you can learn any other relational database. That is easy. But here the concept is different. Some will be graph based, like there is Neo4j, that is graph based database that is used by Facebook for make this. And then you have this columnar databases like H-based, Cassandra. Okay. Then you have other key value type of databases. So there are Redis. Then there are document based database like MongoDB, DynamoDB, and uh, all these are many NoSQL databases that are used in the market, and also there is a combination of these NoSQL databases used sometimes. So you cannot just learn one and do. So it's better when you go for a when you go for a job, then if you know one of the NoSQL databases, that is fine, because you never know that company will be working in which type of NoSQL database. Anyways, you will have to learn there. So learning NoSQL is not a very difficult task. You can, we'll be telling you HBase, that is one of the NoSQL databases. Okay. Uh, why you are not able to install Cloudera, Deepjyoti? Okay, 2 GB RAM. So will you be able to, can you extend it? Is it possible for you people to extend your RAM? So how will you, otherwise, uh, but for free trial also you need to have a credit card. Like there are some sites that are offering this real-time cluster where you can practice for free, but they will ask the credit card information, and after 30 days they will start charging you. Maybe after, not 30 days, after 6 months or like that they will start charging you, and for 5-6 months your trial will be free, kind of. Yeah, AWS. I'm talking about AWS. No, no, that is free, but you have to give your credit card information while registering for that. No, no, risk is not there. I have already tried that. But risk is this, that before the trial expires, you need to register yourself. Otherwise, it will start cutting money from your credit card. Any other question? Yes, Sajid, now you can take over. This is from my side. From tomorrow, we can start with SPFS.
Yeah. Thanks, Ruchita. Thanks for the wonderful session. So, guys, I'll be sharing you the document, okay, document related to installation and whatever slides which we have covered till now, okay. And let's make this thing very clear to you. 2 GB, 4 GB, 2 GB will never work, okay. 4 GB is doable, okay, but having 8 GB is preferable, okay. And guys who have don't have, who cannot like increase the RAM, go for AWS as Ruchita mentioned. They have free 1 month of trial. Okay, use it, give your credit card details, but make sure before 1 month you unregister yourself. Okay, that is doable, and it is not, there is no any risk in that. Okay, and fine, then let's start tomorrow. Okay, at the same time we'll log in and we'll start with the other concepts. Okay, and link of the recorded video will be shared to you shortly. It will be uploaded in YouTube, and it will be a private link so that only you can access it. Okay, and yeah, fine. So thanks a lot for attending. Okay, see you tomorrow. Bye. Bye, Ruchita.